So with that, what I want you to start out with is the timed assessment demos. So normally I would have done this next week because this is actually in the, it's kind of ironic. The 1 week where we do have a weekly time aside to actually do the timed assessment because it's a Thanksgiving week. And these are actually due not during the Thanksgiving, it's due Monday after. But because of the Thanksgiving week, I can't do this next Friday. So I'm gonna do it today. So let me start with the multiple choice timed assessment. And I'll do it the way I've been doing the multiple choice timed assessment. The first way in which I'm gonna do it is cheating. Don't do it. I'm not demonstrating anything that you should be doing. So again, please don't, when you are doing these timed assessments, please do not do it the way I'm gonna do it here. Again, it's cheating for multiple reasons. I don't think anybody using generative AI during any kind of exam, any kind of summative assessment thinks that it's not cheating. And two, because this is a form of a summative assessment, I did put in a note, no outside help, whether it's a generative AI or anything else. I think this is just this should be confirming your moral sense that you already had. As you are doing a timed assessment, if you are getting help, it's not honest. So again, I'm not demonstrating anything that you should be doing. Let's just call it me as an instructor, just keeping on top of what technology makes possible. Now, it is possible for you to use generative AI in a way that's academically honest, and that is in study. So after you've done your attempt, let's say you are trying to figure out what questions you missed, or maybe even the questions you got right. Maybe you don't quite understand why it was graded as right. Then you can use generative AI. Use it as a tutor. Get some help from it, get some explanation. That is totally fine. You can do it outside of the time limit after you've submitted. That I fully endorse that use of generative AI. You just can't use it during the assessment itself. So I'm gonna do this twice. The first way, it's not a demo. Don't do it the same way, but just so that I know how capable ChatGPT is at the moment. And the second time, I'm just competing with the ChatGPT. Depending on how the first attempt looks, I'm going to be competing either on both on accuracy and time, or if ChatGPT is accurate enough, then I will give up competing on time so that I can make sure I can continue to compete on accuracy. So with all that, before I start, I should give ChatGPT a prompt that'll help me cheat more effectively. Sorry, effective is not the correct adjective there, but this is a prompt I need so that ChatGPT is as quick as I need it to be as I'm cheating. So let me say, hi, I'm working on electromagnetism and circuits multiple choice question set. With each question I'll post. Could you answer right away? A, B, C, etc. Followed by a short explanation. Thank you. And as I've said before, ChatGPT, it's an amoral tool. So, and by which I mean, it's neither good nor bad. What makes a tool good morally is someone using it. So right now I'm using it in a bad way. And it's not because ChatGPT is bad, it's because test student is a bad cheating student. Anyways, let me get started. So I'm gonna click start. And I'm just gonna go through really quickly. In my other class, I could do this as quickly as 3 minutes. So that's really what I'm trying to beat right now. So, I mean, it's kind of counterproductive in the sense that the quicker ChatGPT is in answering, the higher hill I have to beat in trying to compete with it. So why would I do that? But I thought it would be fun. So at this point, I'm doing things because I think it's fun, not because there's any reason. T line integral always, yeah. That sometimes it's given me wrong. Like the choice that it told me didn't always match. That's why I'm reading it to make sure that it's actually the number of the choice that it claims it is actually matches. So yes, the motor rotates without a load. Yeah, but even with the possibility of numbers being wrong, it's still helpful to give if it gives me the number, because it's the kind of thing that I can double check more quickly than to come up with myself. Like if I'm trying to match up the numbering, it'll take me a few precious seconds. But if I've given, yeah, so I can see that it's saying L squared, then that's wrong. So, but I don't see anything else that would match, so I'm just gonna go with it. So, um, um, C doesn't have L squared. Let's just try to get the correct thing. Mm. Oh well. So we'll go with it. I think you might have missed that question, but we'll just not waste too much time. C given the same rate. Yeah, so once it, because I think the main efficiency is that once it gives me the choice, then if it's the right choice, I only have to read one. So I think that saves me a few seconds, and over 10 questions, that adds up. I guess that must add up to like a minute. That's probably why in the other class I could do this in 3 minutes instead of four, because previous to that 4 minutes was kind of my limitation in how quickly I can copy and paste. So let's see. Yeah. Paste it in two steps. So B probably. Alright. Alright, that's the question 9, and the last one, question 10. Question 9, first graph, exponentially decay. Wow, yeah, that's a good description of. I mean, I don't know if it's correct because my physics brain is turned off. I'm not thinking about questions, but that is an accurate description of the graph that it was given. Yeah, that's correct. And yeah, anyways, let's make sure that it answered all the questions. And I guess I must take like between 3 to 4 minutes based on that. Let's submit and end. Maybe I spent 3.5 minutes. Oh wow, that is bad. So let's make sure that I didn't, that it missed so many. It's not my fault because it's possible that you gave me the correct answer, but maybe I didn't paste it correctly. It's possible. So electric field. Yeah. So here the challenge would be that. So I have the answer memorized in terms of the permeability of free space. So in terms of permeability, it should be b squared over 2 mu naught, the permeability. But then you now have to convert to this, which I don't have it memorized. So let me read through ChatGPT's explanation and see if that matches. Yeah, so this is correct. And it's getting that, yeah, k is that, c squared is that, yeah. So c squared, if c squared is in the denominator, it looks like it's putting mu naught in the wrong space. Is that right? No, I think no, this is correct, and I do it based on process of wait. It's either this or this. Let me do it by hand. I can't. Trying to do this in my head is giving me headaches. And in fact, let me keep ChatGPT missed, and I'll keep track of what it missed. And here, let's just work this out. So I do know UB should be b squared over 2 mu naught, and I guess I'll use what it's written, that k is equal to 1 over 4 pi epsilon naught, that's right, and c squared is equal to 1 over mu naught epsilon naught, which means mu naught should be, well, let's do two things, not at the same time. Let's write down epsilon naught first. Epsilon naught is 1 over 4 pi ke out of here. And then I can now write for mu naught in terms of c squared and epsilon naught. It's going to be 1 over c squared epsilon naught. So plug in epsilon naught, you get 4 pi ke, reciprocal of this, divided by c squared. So I guess that's right. Oh wait, so that is mu naught, but mu naught is in the denominator, not the numerator. So plugging reciprocal of this, it should be c squared b squared over 8 pi ke. Yeah, so it should have been that. So okay, ChatGPT missed question 1. And I'm looking for 6 questions that it missed. I'm actually quite surprised that it missed the question 1. But okay, it missed. And it's not my fault because that's the answer that it gave. I entered it correctly. Question 2. I think that's probably right. Let's see. Considering all the laws, electric field and magnetic field, line integral of around electric fields are always, it's not always a zero. Once you have time, Faraday's law. Faraday's law makes it so that this is not always zero. So you missed this. The correct answer would have been electric fields can be produced electrically or by magnetic fields from electric currents. This is correct. While electric fields only produce forces that conserve. Now, surprising thing is magnetic forces actually conserve mechanical energy. Static magnetic forces, anyway. Yeah, this is wrong. Same reason this is wrong. It's a Faraday's law that gives you counterexamples here. So it should have been the first choice here, which is correct. This is the Coulomb's law or Gauss's law, and this is now Faraday's law. So ChatGPT missed that. So missed the questions 1, 2. Let's keep going. What else did they miss? Question 3. Electric motor. Current is passed. Polarity. Commutator. Working of this motor. Okay. Let's as the motor rotates without a load, the maximum current is. Oh no, that's wrong. It's a maximum. Or I guess this might be right, but the maximum rotation rate, it's capped by the voltage, the induced voltage or the back EMF will limit how fast the motor can spin. So this is wrong. So ChatGPT again missed the question 3. I guess it maybe doesn't quite fully understand the Faraday's law. It's missing all the questions having to do with the Faraday's law. So it would be, so this is wrong because I think I may even mention the commutator. So electrical arrangement, yeah, it does function as an inductor, which it describes, yeah, because the inductor kind of gives you an entry into the idea of back EMF or induced voltage. So this should have been the correct choice. Let me just read the next one to make sure. Constant voltage is applied, same amount of current under all situations. No, so this is wrong. how much load it has to, how much torque it needs to apply does kind of change. So, so yeah. This is the correct answer, and ChatGPT missed that. Not through my fault. It just missed it. I mean, you could argue, but given like number 4 is definitely wrong. Because maximum, yeah, the resistance of coils is not what determines the maximum current. So it's a because as the motor rotates, there is back EMF generated. That is really the main thing that determines how fast it spins. So given that, even with some deficiencies in this description, it's the better choice. All right, question 4. Correct answer is, oh, right. Can I do it by dimensional analysis? What is the correct expression for the magnitude of current around the loop? So the voltage should be, this might be the correct voltage. Let's see. EMF is that. And yeah, I think this is just hiccuping. This is nonsense paragraph. This is fine. So okay, that's correct. ChatGPT didn't miss question 4. Question 5. Yeah, corrected explanation. Yeah. Incorrectly describes Ohm's law. Same voltage, resistor smaller, more power. Yeah, that kind of comes from power. It has 3 different expressions you can use. For this scenario, I would use P is equal to V squared over R. So yeah, correct answer. Yeah, that's exactly it. Okay, question 6. It answered D. Yeah, that's the correct statement of Ohm's law, and it's competing with this choice. And voltage across current through a resistor is proportional to voltage. Yeah, that's the try. What's wrong with that? Voltage across a resistor is proportional to its resistance. I mean, I'm inclined to say this is the better choice, and this would be well, it's kind of what's been kept constant. You could, if you had a setting and you increase the resistance, what's more likely to happen is the current would decrease. Let's see how correct equation, essence of emphasized voltage, not the. Yeah, I think this is perfectly fine. So I'm pretty sure it didn't miss question 6. We'll see. There should be other 3 questions that it missed. So question 6 is tricky, but got it right. I got no issues. Let's look at question 7. Open circuit voltage. So it should be R1 of that. So it should be 1/3 that it's measuring here. Oh, yeah, that's not 1/3. It should have been this 4 volts. So that feels like a current, a correct current. Yeah, that's correct. Why did they say that's correct? So ChatGPT missed the question 7 on technicality, in that the choice it gave me was wrong, but the explanation it gave is correct. Like, this is fine. That's not wrong. It's just that it told me the wrong correct answer. But all right, so that's fine. Let's keep going. This circuit here, switch is closed after a long time, meaning the capacitor, it is fully charged, no current through it. So it should look like just a resistor network. So this should be well, how much current? So 6 volt divided by 3 ohm. Oh, it should be 2 ampere. And I think I remember seeing this. Yeah. It calculated the correct current and then gave me a wrong answer. So it missed the question 8 again on a technicality. Its explanation was fine. It just gave me the wrong choice. Uh, I guess maybe I should have kind of double checked it, but I don't know. That would have slowed me down, so I don't think I would have done that. But ChatGPT could have gotten, 2 out of its 6 mixed questions actually right. So this one, at time equals 0, it's a flipped. Until time equals 0, the capacitor has been charging. So you are starting out with a charged capacitor. It's gonna discharge. Voltage occurs. Yeah, that's correct. Discharging, exponential decay. Yeah, that's exactly what you should see. Looks good. If we asked for current, it would have been the same thing, I guess. Yeah. All right, question 10. So it must wait. I didn't think we missed the question 10. So what did we miss? I might have to go into instructor mode to look for what did we miss. So this I thought was correct. That's the time varying electric flux, being able to generate, act as a current and generate magnetic field. Yeah, that's correct. And that's only 5. So let me go in. That's possible. It's possible there's a programming error. That's happened before. So let me do this. I'm gonna just bring up this screen from my on my other screen so that I can go in with my instructor view and not click through anything that it's sensitive that people can see. Let's see. Yeah, test the student. So okay, so this is according to programmed in answers. So that was wrong, right? That was wrong, and this was wrong, and that was correct. Wait, what? Oh, I know what I missed. Incorrectly. As I was saying, this is correct. So, so the incorrect choice should be this is incorrect. Ohm's law actually it only happens for medium that dissipates energy. So it's not about constant acceleration; it's more about constant speed because of dissipation of energy. So yeah. So at least no programming error. It missed the question number 5. So where it was, let's look at question number 5 explanation. So it says that this there's incorrect because it misread smaller resistance dissipates more power. So I mean, using the correct formula, misread the question, and this is actually wrong. It's just straightforward wrong. So I guess it is true that a conductor that you could associate resistance to has free charges. So that part is right. And it's right that the voltage being applied across that distance means that there's some electric field. So there is a constant applied electric field. Now, what's wrong is that in order to get Ohm's law, that free charge that's being accelerated by electric field, it constantly has to lose energy. So those charges are colliding with something like there's some sort of collision center, which means the free charges themselves, they don't experience constant electric field. There's constant applied electric field, but in its interaction with the material, it's experiencing varying electric field due to the microscopic the material things. So it's a tricky question. So this sounds right, but it's wrong. And I guess the thing that will help you remember, understand, recognize that this is wrong is to remember that Ohm's quote-unquote law, it's not a universal law of nature. It's actually one of those misnomer laws. Ohm's law always is involved with the loss of mechanical or electrical energy. So if this description sounds like it's describing a situation where energy is conserved, that should give you a kind of ring the alarm bells that that must not be right, because Ohm's law involves loss of energy. So, all right. So those are the 6 questions that ChatGPT missed. I'm quite surprised that it did so badly, and I'm encouraged that I can try to beat it. I think I can try to beat it both on time and accuracy. So let's do it. So my goal is now going to be to beat it both on time and accuracy. And on that, so I'm gonna go really fast. Oops, wrong screen. I'm gonna go really fast. So for it to beat its time of 4 minutes, I have to go really fast. I'm gonna be going fast enough that I'll probably make a mistake. But as long as I don't miss 6 questions, which will be unlikely, I'm gonna be able to beat it both on time and accuracy. That's my goal. And whatever questions I miss because I'm going too fast, I'll come back and give you the correct answer. And I also won't be explaining a lot because for me to go faster than 4 minutes, I have to just concentrate on thinking and not talk or explain a lot of stuff. So let me just go. Dimensional analysis. And this is what I was talking about earlier. Double checking. Use a calculator. Oh, yeah, so I'm benefiting from previous look at it. We had a lab on this, which is why I think it's fair to ask. Yeah, just double checking. No, more quickly. RC is smaller. Yeah, RC is smaller. Too elementary. No. Yeah, it's stated in a really confusing way, but that is the correct choice. Oh, no, this is better choice. Yeah, and it's less confusing. Oh, I think we had this question. let's make sure I answered all the questions. 10 out of 10. I don't think I beat ChatGPT on time, did I? Let's see. So ChatGPT exactly spent 4 minutes, and and I beat it on time because I spent 3.9 minutes instead of 4 minutes. And so I answered all the questions correctly. I guess briefly explaining, let's go to the actual graded attempt to this one. So I think I talk about this in the lecture, that Lenz's law, if you imagine it being the other way, you would get like a free energy. Like in this scenario, this would just like speed up on its own spontaneously. That so Lenz's law kind of makes sure that you don't get free energy like that. So that's why this is correct. This, I just checked the units. So I know it had to be right word, because from conservation of energy consideration alone, this is just wrong. And between these two, this I knew it had wrong units to be a force. Like without working it out exactly, this was wrong. So this must be right. And here, I think we already talked about this one. And here, I think this isn't that tricky. It's just part of this law. This I just had to do the calculator. We looked at this one before. And this is the, we had a setup in the lab. This is circuit 4 in the intro to circuits lab that we did. It's kinda. So reducing one of the resistances increases the overall current. That means I squared R hitting for the resistor that remains at the same R will be bigger. So that's what this is. Here, so I'm just, these are all long descriptions, but I'm just looking at the RC constant, time constant for RC circuit, which is R times C, and I'm kind of comparing the description with how that R times C would change, and this last one is the only thing that matches. Smaller time constant means a quicker change, and that matches with the smaller capacitance. And here, the thing that was confusing me here was the voltage imposed across the resistor, that because of the circuit arrangement also happens to be the voltage across the inductor. And that's what I was thinking about. And given no other choice, I would say this is correct. But given this choice, this is the better choice, because it's really the voltage across the inductor. And the inductor has that fundamental relationship for an inductor. I have it memorized as a definition of inductance. Definition of inductance is a voltage divided by rate of change of current. So, or self-inductance, I guess. So, and this is what also tells you, looking at it this way, rewriting it to kind of make the causal relationship clearer. So the voltage difference is equal to L, some constant, times, and this is what's causing the voltage, the rate of change of current. So, so that's basically what the last choice says. And I think a very last question, we talked about that. Same question as well. There are actually 4 questions that could be your question number 10. I just happened to get the same question twice, which is, I guess, unlucky for you, which means if you get one of the other 3 questions, you won't have seen it. But do your best. Your grade on your score on the multiple choice timed assessment, it doesn't determine your grade. Treat it like a practice. I think it'll be fine. So yeah, that's this attempt. I think if there are any questions, I'm happy to answer. No questions. That's my so I can still be ChatGPT, because I think we are probably at the topics where ChatGPT isn't so good as earlier set of topics which were more elementary than what we are covering now. So I can still beat it on accuracy and time still, but at a risk of missing 1 or 2 questions, which I didn't do this time. But like if I do this 10 times at the speed I was going, I wouldn't be surprised if I miss 1 or 2 questions on each attempt.